Hey howdy folks, welcome to a special edition of Virtual Schmied featuring my disembodied voice, but my actual hands. So today we are talking about the gold foil experiment, also sometimes just called the Rutherford gold foil experiment. He was one of the guys that did it. So you might have this handout. What we're going to look at is a top-down view of the gold foil experiment. That's what we're looking at right here. We're also going to look at a very thin gold foil, and we're going to sketch that, and then we're going to talk about the two conclusions that he was able to draw from these results. Okay, so here's the setup. What I'm showing in black here is a detector screen. And what this screen detected was if an alpha particle ran into it or not. So Rutherford also set up a source of alpha particles over here. So we had something radioactive, and it was shooting out these alpha particles. We'll come back to what an alpha particle is in just a moment here. He also, in the middle of this, set up a very thin sheet of gold foil. Now I'm just using a little yellow piece of paper here, and this is actually way too thick to show how thin the gold foil really was. But we'll come back to the thinness of the gold foil in just a little bit here. So we put that in the middle of his detector screen, and then he shot alpha particles at it. Let's talk about what an alpha particle is. So an alpha particle is a tiny, positively charged particle. It's much smaller than a gold atom, and he got them moving really fast. That's what I'm trying to show with his little whoosh lines there. So an alpha particle, the important parts are that it is small, it is positively charged, and that it was moving really fast. Okay, so he has a source of alpha particles, and he's shooting them at this gold foil, and then he's able to detect what happens to those alpha particles when he does that. So I'm going to set up some of my alpha particles here. So he's shooting alpha particles at this sheet of gold foil, and what he finds is that most of the alpha particles go just straight through this, like that gold foil wasn't even there. The alpha particles shoot straight on through, and then they come and they hit this detector, and they make this detector light up somewhere on this side, and he's able to see that. So the vast majority of the alpha particles go straight on through. Some of those alpha particles, well, let me sketch the ones going straight through first. So most of these alpha particles go straight through this gold foil, and they come and they light this detector up. Some of those alpha particles, however, do something slightly different. Some of those alpha particles just get deflected, but just slightly. So some of them come through, and they just make a slight turn. Or some of them came through, and they just make a slight turn, going the other way. So some of those alpha particles made just a very slight turn. I'm going to show those in like a kind of purpley color. So some of those alpha particles came straight on through, but rather than just passing straight through the gold foil, they sort of deflected a bit. Or maybe instead of deflecting up, they came and they sort of deflected downwards. So some of those alpha particles didn't go straight through, but they went a different path, and he was able to again detect those alpha particles either hit up here, or maybe it came down here and hit. But very occasionally, Rutherford would see an alpha particle that came through, shot out of his detector, and came and hit this gold foil, and instead of just going straight through, or instead of just veering off slightly, they came and they went ping, and they bounced almost straight backwards. So they went ping and came back, and he was able to see it on this side of the detector screen over here. So very occasionally, he would have an alpha particle come through, and it would hit that gold foil, and it would hit something in that gold foil. He wasn't sure what yet, but it would hit something, and then it would come back and make the detector screen light up almost opposite of the way that it came in. So the detector screen would come over here, and it would light up on this side. Okay, so to kind of recap, we've got our source of alpha particles over here, and Rutherford is shooting those alpha particles. An alpha particle is just a small positively charged particle that's moving very fast. and he's shooting it at this gold foil. Most of them go straight on through. Some of them get deflected, and some of them get bing, and they come back and they come like they were deflected off that screen rather than just deflected slightly. Okay, so let's switch our view to looking at this very, very thin sheet of gold foil. So I'm going to get rid of this experiment. We're going to zoom way in on that gold foil there. Okay, so Rutherford used gold for a very specific reason. Not just because it's shiny and neat and has other cool properties, but he used gold because gold is very, very malleable. And what that means is that he's able to get gold into very, very thin sheets, even thinner than this piece of paper. This piece of paper is far too thick to show how thin the gold foil is. And in fact, that gold foil was so thin, it was just a few atoms, maybe 3 to 10 atoms thick. I'm only drawing a couple atoms thick here, and this is what I'll have you draw on your view for our top-down view of the very thin gold foil. So let's sketch again what happened to most of those alpha particles as they came straight through. I'm going to need my green, my orange, and this color. So we know that most of those particles just went straight on through. I'm going to sketch those in green. So a lot of particles he shot, and they just went straight through. Like nothing was even there to stop them, because in fact there wasn't. We'll come back to that point. So sketch a bunch of these particles, these alpha particles, just shooting straight through and not doing anything. Sketch some more of these particles in a different color if you have it. Some of these particles would come through, but they would kind of get deflected. Some of these particles would come through and they would kind of get deflected. And then occasionally there would be a particle that would come through and it would run into something and it would bounce almost straight back. Occasionally there would be a particle that would come through, it would run into something and it would bounce straight back. So our view of the atom here is missing something important that Rutherford wasn't sure was there yet. But here's why he saw what he saw. These atoms all need nuclei. I'm going to draw in all my little nucleuses. So what he noticed is that the ones that didn't just go straight through, some of these alpha particles came and they kind of got deflected. Or some came and they hit that nucleus head on and they got bounced straight backwards. So here are the two conclusions from Rutherford's gold foil experiment and how he knew. Conclusion number 1. The atom is mostly, like more than 99.999%, empty space. And he knew that the atom was mostly empty space because most of these alpha particles just went straight through without really being stopped by anything because there was nothing there to stop them. His second conclusion is kind of the more important one. That what isn't empty space in the atom, that the nucleus is small, but also dense and positively charged. He knew it was positively charged because when these positively charged alpha particles came through, they would get to this nucleus and they would get just veered slightly off, because we know that when two positive things come together, they want to repel each other. If two positive poles come together, they want to repel each other. So that's how he knew it was positively charged. Rutherford was also able to figure out that the nucleus must be very small and very dense, because very, very occasionally, one of these particles, one of these alpha particles, would come through, run smack into that nucleus, and rather than breaking the nucleus or going through it, would come back and be reflected off. That told him that the nucleus must be very, very dense for it to repel that really fast-moving alpha particle. Alrighty, folks. That's pretty much the Rutherford gold foil experiment. There's a little bit more to it than that, but I wanted to try to keep this video short. So this has been a special edition of Virtual Schmied. Out.